Avi Loeb is a theoretical physicist who works on astrophysics, astronomy, and cosmology. He's a professor of science at Harvard University, the founder of the Galileo Project, and in 2023 he travelled to Papua New Guinea to search for debris from what is believed to be an interstellar object. His latest book is titled Interstellar: The Search for Extraterrestrial Life and Our Future in the Stars. If you want to watch my first interview with Avi, please see the link in the description below. Thank you so much for coming back and doing this with me again, Avi. I really appreciate it. To start us off, can you tell me a little bit about your upcoming book, Interstellar?
Thanks for having me. It's a great pleasure. The book is coming out in August 2023, and that's the way it looks.
It looks good.
And it can be pre-ordered already a month in advance in all outlets that sell books. And it discusses the question of what would be the implications of finding a technological gadget that originated in interstellar space, that was manufactured by an extraterrestrial technological civilization. And obviously, just the search for that already would change humanity, because it would imply that we are open-minded, that we are willing to learn, and that we are studying it agnostically, whereas as of now, people have strong opinions without seeking evidence, which is unfortunate. It's sort of like dating, where meeting a partner would change your life, but even just seeking a partner changes your life. And I discussed the various ways by which we should remain humble and seek the evidence, because that's the scientific method. And the latest example of that is the expedition that I led to the Pacific Ocean. We can speak more about it.
Yeah, absolutely. Yeah, we're going to come back to that. I like the way you use the word agnostically. It's a word I don't often hear used in, UFO, UAP, in regards to that, but it's a great way of putting it, because, we don't know, but we must stay open to it.
Well, I approach it like a kid that is learning about the environment. And in this case, it's our cosmic neighborhood. And of course, you can say whether we have neighbors or not based on your prejudice. And Enrico Fermi stood there and said that, where is everybody? But that's just like a single person standing at home and saying, I don't see any partner around me, therefore I may not have partner. But in fact, in order to find partners, you need to go to dating site. At the very least, you need to look through your windows with telescopes, or go out to your backyard and search for any objects that came from the street. That's a very elementary thing to do. Check your mailbox, check your backyard. We insist that anything we will find in the backyard would be stones, rocks, things that we know about, like asteroids or comets. But only over the past decade, we started detecting objects that came into our backyard, the solar system, from interstellar space. And the first three of them looked unlike the asteroids and comets that we are familiar with. So, it's sort of like finding a tennis ball that was thrown by a neighbor, or objects that came from the street that can educate us about the nature of our neighbors. And it's just a new method that was not practiced as of yet. And when people say we haven't seen any evidence, it's because they're not seeking evidence. It's a self-fulfilling prophecy. Elon Musk said, well, I'm a space guy and I should have seen it by now. But the point is, he knows about the nearby environment where the Earth orbits around the sun. And, that environment is just 1 part in 10 to the 15, or a quadrillionth of the size of the universe. Okay, so it's just like an ant surveying the head of a pin and trying to express an opinion about the most distant planet in the solar system. That's the range of scales we're talking about. It's really inappropriate. And of course, you need to look for evidence before you find it. It will not land on your lap. Just in the same way that, when we seek for dark matter, we don't expect it to be obvious. I mean, we have searched for it 40 years. We haven't found it. We know that most of the matter in the universe is not what we find in the solar system. So here is an excellent example where our experience locally is not a good example for what lies out there. 83% of the matter out there is not the type that we're familiar with in the solar system. And yet we keep searching for 4 decades, investing billions of dollars. We haven't found it. And the question of whether we are alone, or we have another technological civilization, or many more that preceded us, is of much more interest to the general public than the nature of dark matter. Yet we are not investing anything in it. And we're claiming, we think it's an extraordinary claim. That's what many scientists argue. It's an extraordinary claim to consider something like us. Well, I think it's not extraordinary at all, because we know that we exist, okay? And we know that we are sending probes to interstellar space that in the form of Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. And they will become space trash in interstellar space in 10,000 years once they exit the Oort cloud. And so we can search for trash that other civilizations send, because these objects are bound by gravity to the Milky Way. They're moving at a tenth of the escape speed from the Milky Way. They're gravitationally bound to the disk of the Milky Way. And so they keep accumulating over time, just like plastics in the oceans. So we only started the search a decade ago for interstellar objects. And guess what? The first three look really strange. There were two meteors that we can talk about, and they had material strength that was well above solar system rocks. And moreover, they were moving really fast, even relative to nearby stars. And then we had Oumuamua, which was 200 times bigger. These meteors were meter scale. Oumuamua was the size of a football field, and it was peculiar because of its shape. It was flat based on the reflection of sunlight as it was tumbling. I mean, this is not my paper. It's a paper by an astronomer that was written a year after Oumuamua was discovered, after detailed analysis. It appeared to be flat. And moreover, it was pushed away from the sun by some mysterious force without showing any cometary evaporation. So it was not a comet. If you open Britannica, you see the definition of a comet. It did not satisfy that definition. Now you can say, well, maybe it's a comet of a type that we've never seen before, like it emits hydrogen, nitrogen, maybe it's a dust bunny. These were the suggestions from the mainstream. It looks like people are trying desperately to explain it in terms of something we've never seen before. And, saying that it has a tail, a cometary evaporation cloud around it, without us seeing it, reminds me of the story of Hans Christian Andersen, where the kid says, the emperor has no clothes. I say, this object has no cometary tail. And people say, no, it does. It's actually transparent. You can't see it. And just like the emperor has, And my point is, these are possible explanations, of course, that the emperor may have invisible clothes. But the most naive and straightforward realization is it doesn't. Okay, we see the emperor is naked. We see an object that doesn't have a cometary tail. And based on our experience, that's the definition of comets. Okay, so now you can say, well, maybe it's something completely different. Of course, it could be something completely different, but we have to recognize that this is an anomaly. It's an outlier. It's not something typical, because there was a third object. And then there was a fourth object, and the fourth object, after the two meteors and Oumuamua, the fourth object looked just like a meteor, okay? Just like a comet, a regular comet. It had a cometary tail, just like the comets we had seen before, okay? And it was called Borisov, after the name of the discoverer. And everyone, wrote papers and said, yeah, it actually is very similar to the comets we are familiar with. Okay, so suddenly something that looks familiar, is accepted, and everyone says, yeah, that's the way it should. But then when an object doesn't look like a comet, they say, yeah, it is because it's interstellar. But here is an interstellar comet that does look like a comet. We know the fourth object. So the third one cannot be the same, and you cannot argue that all objects in interstellar space turn into comets of invisible tail, because the fourth one had a visible tail, just like the ones in the solar system. So the reason that you expect everything to be comets like the solar system is because the outer parts of the solar system is made of icy rocks that where the water is frozen on their surface, and they are the most loosely bound objects to the sun. So it's very easy for a passing star to kick them out of the solar system gravitationally. They have the characteristic orbital speeds are about 100 times lower than the Earth around the sun. So it's very easy to basically dislodge them from the source. And you would expect interstellar space to contain mostly icy objects from the outskirts of planetary systems that would behave like comets as we know them. But the first three objects did not. So my point is that we should be open-minded, and rather than resist new knowledge, basically open our minds to possibilities that we haven't forecasted before.
Yeah, absolutely. I couldn't agree more. Follow the evidence wherever it leads. I've got a question here from one of my patrons. I actually considered opening with this question because I know it's one that you'll enjoy answering. He wants to know, it's Jimmy the Earthling, and he wants to know, Dr. Loeb, what do you find to be the most exciting thing about astronomy?
The most exciting thing is that the third dimension, that we are not usually exploring. We live on a two-dimensional surface of a rock that we happen to be born on. But if you explore the third dimension, you find conditions that are completely different than we experience, and that allow us to, first of all, discover new physics, because those circumstances are so vastly different. And also imagine ways by which we can extend our longevity. So that applies to us humans. We live on this rock that we were born on. We have just 1 billion years left, irrespective of how well we treat global warming as a result of our own actions. The sun will introduce a huge global warming effect on Earth. In about 1 billion years, it will create a greenhouse effect because it will warm up. It will become, the sun will produce more light in the next billion years, such that it will boil off all the oceans on Earth. Okay, so we have no way of staying here, but there is an easy solution. Instead of being stuck on this rock that we were born on, we can just create a platform that can move away from the sun just the right distance, or even go to another star, like the nearest star, Proxima Centauri, will live for 100 times longer than the sun. So we're talking about trillions of years, and instead of 10 billion years. So, we might go to another star. We might just go a little farther from the sun as it warms, as it heats up, becomes more luminous. But the point is that we need to break this situation we were born into, where we are stuck on this planet, and recognize what's out there that could help us survive in the long term. And we are using the energy that we harvest from this star, which burns hydrogen, as a nuclear fusion reactor that is bound by gravity. But we can create our own nuclear reactors, and by that free ourselves from the need to be next to a star, in fact, and just go anywhere we want. So by looking in this third dimension, we can explore the opportunities that we have. And I bet you that there were other technological civilizations before us that consider that. So finding them would help us plan better, because they may have confronted the same challenges and may have found solutions to go into space. And realizing what they found can give us a leap into our technological future. So that's a very important aspect of humanity, as how to behave more intelligently, because as of now, we are wasting a lot of resources on fighting each other on this rock for just reasons that are completely, how should I say, they look ridiculous in the big context. And if we were to appreciate the third dimension, perhaps we would wake up and say, wait a minute, we are wasting our energy, time, and resources on irrelevant, unimportant tasks, like fighting each other, occupying territories, telling each other stories. It's not really about that. The long-term survival should be in space, and space exploration, science and technology should be our future. And once we realize that, we will probably be admitted to the class of more intelligent civilizations out there, because they have figured it out. There is the notion of survival of the fittest, an extension of the Darwinian principle, but to intelligent civilizations in interstellar space. And I very much hope that we will see that future. But beyond that, there is this curiosity about how did we come to exist? What is out there? How did the universe start? What was there at the Big Bang, and perhaps what happened before the Big Bang? How did it happen? These are really questions about our cosmic roots, and they're fascinating. So to me, the universe delivers that message of where we came from, and that's so not only where we are going, the thing that I was talking about, but also where we came from. Of course, the fundamental question is, how did the universe come to exist? Was it generated in a laboratory by some scientists in white coats that knew about quantum gravity and figured out how to make a baby universe in the laboratory? That's an interesting possibility. And of course, religions give answers, but the way I see it is that science is the way for us to gain knowledge about the reality that we all share. And, the answer may not be different from, very different qualitatively from what religions talk about. There may be some some entity out there that has much more power than humanity has, and is responsible for a lot of the things that we take to be natural, but in fact they were created by some technological process. And it's sort of like if you think about Moses encountering the burning bush that was never consumed. If I were next to Moses, I would offer help using the infrared sensors that we have at the Galileo Project, and telling Moses exactly the temperature of the bush, the energy output per time, and trying to figure out if indeed this is some sign of a higher level of a higher entity, higher being that created something that is not really natural. And of course, it would have enhanced the awe that Moses would have had. And he used this miracle, quote unquote, as a testimony to the existence of God. But the same awe can be experienced by a cave dweller looking at a tablet, okay, or by Moses himself, if he were to get the 10 Commandments on a tablet connected to Wi-Fi a few thousand years ago on Mount Sinai. So the point is studying what is out there, how did we come to exist, and finding evidence for intelligence out there that could help us figure out what our true potential is and what really was responsible for what we see around us. These are fascinating aspects of studying the universe, in my opinion. And of course, it's all on top of the knowledge we gain about the material universe. What is the dark matter? What happens inside a black hole? These are fascinating questions in physics. But the connection to spirituality comes from our cosmic roots, where we are going, and what's the importance of intelligence in shaping what we see around us.
Beautiful answer. Nice one, Avi. Since we last spoke, it's been almost exactly a year, about 12 months, roughly. In that time, a lot has happened. You've been busy. You've been working on the Galileo Project. You've been on your expedition. You've been writing papers with Kirkpatrick. There's been all sorts going on. And then in the wider world of UAP, there's been, NASA have been getting involved. We've got new hearings coming up. Obviously, whistleblower David Grusch. There's been, all sorts happening. It just feels like a real whirlwind. How would you sum up the last 12 months? What do you make of it? How has the landscape changed since we last spoke?
Right. So obviously the government is speaking much more about this subject, and that comes from Congress. It comes from within the Department of Defense in the form of Grusch. And the fundamental question there is whether there is any fire behind the smoke. So you see a lot of smoke. David Grusch did not witness personally the materials, the studies that are being done, according to him. He just heard about it from other people and saw documents to this fact. And he seems to be a credible witness, except that he did not witness the actual thing. Okay, so he witnessed other people talking about the actual thing. And Therefore, it leaves open the question of whether there is an actual thing out there that the government, some materials from a crash site that the government has in its possession. And most recently, the Senate Majority Leader, Chuck Schumer, made a statement just a few days ago that he would like the government to reveal what it has in its possession, to clarify what it knows about unidentified anomalous phenomena. And that is a very positive motion that, they are trying to add an amendment together with another Senator Rounds, who is Republican, together with the Democrats. So it's a bipartisan effort. And it shows that some people, at least in Congress, suspect that there is something that the government keeps under its veil of national security. So if that's the case, eventually, hopefully we'll know about it. I'm not holding my breath because government is very slow to respond, and it's also not a scientific organization. But obviously, their day job is national security. Okay, so that's the job of Department of Defense, intelligence agencies, and because they monitor the sky, they would be the first to notice something unusual. Okay, so I can understand how they might be the first to notice unidentified anomalous phenomena as intriguing, as not being human-made or natural. There is a very reasonable likelihood for that to happen because scientists, like astronomers, are looking far away. They don't care what happens close to Earth. And the government cares about what happens close to Earth, and then they would see something. Okay, and what this something is depends on what they haven't told us. It really is up for us to imagine. I'm trying to follow a parallel path where I say the sky is not classified, the oceans are not classified, so we can collect the evidence ourselves. We don't need to rely on government. Why should we let politicians dictate what we know about interstellar space? That's not a matter of national security, interstellar space. No. So the goal of science is complementary to that of government. Science brings knowledge that should be shared by all humans, irrespective of national borders. Anything coming from interstellar space has nothing to do with national borders. If they made a journey of billions of years from another planet, they don't care how we split the territories on our planet.
And so flags.
Yeah, so my point is it should not be the privy of the President of the United States to know something that the public doesn't know if it has to do with interstellar space, with extraterrestrials. So it has to be shared by everyone. And therefore, I hope that if the government has such information, we will learn about it. But irrespective, I think scientists can find it. And of course, when scientists say it's, extraterrestrial intelligence is an extraordinary claim that requires extraordinary evidence, at the same time, they're not seeking the evidence. So it's a self-fulfilling prophecy. Not only that, but they're blocking others from doing it. When I went to the Pacific Ocean, to the expedition, a week before that, I was told by a colleague, why would you do that? It's a waste of money, waste of time. You will not find anything. That's what we think. And I said, well, I didn't ask you to do anything. You can just sit back and relax. I'm doing the heavy lifting. You don't need to say anything. If I come back with nothing, you can tell me that that's what you expected. But I'm not taking any money out of your research on dark matter, which, by the way, for 40 years didn't yield any result, and we spent billions of dollars on this front. So I'm not taking any of that money. It's money that is allocated to science just for the sake of this expedition. So it's a win-win situation where I'm seeking evidence. I'm just following the scientific method. So why would anyone who calls himself or herself scientist, why would they have an issue with gathering evidence from the site of a meteor? It's wild. There is no negative aspect to it. I'm just trying to collect materials. Perhaps it's a very challenging proposition, but if I find it, I can analyze it and report the results back in a scientific publication. Why is that a problem?
I mean, I think to be against that, you have to take a kind of anti-science stance, don't you?
Yeah,
you have
but
to be against exploration.
Exactly, but the strange thing is that this is advocated by people who call themselves scientists.
Do you
I'm
think
not
it's
talking
because
about the general public. I mean,
no?
for the general public, there is huge amount of enthusiasm. Also for the U.S. government, I mean, I got a lot of positive feedback. But in the public, of course, you have these groups of people that know the answer in advance also, because they say we experienced it, or we have a belief system, just like in religion. That's not the way science is done. Science is not done by believing. It is guided by evidence. And therefore, there is no way out of just seeking the evidence to guide us. It's not a matter of eyewitness testimonies. We can't rely on people. We have to rely on instruments analyzing the data that we obtain. And that's what we are doing right now with whatever we retrieved in the Pacific Ocean.
Yeah. Do you think those scientists that have come to you and said, "What are you doing? Why are you doing this? This is waste of time, waste of money." Do you think they have been potentially or not have been, but do you think they are under the, I'm trying to find how to use the words correctly, but under the weight of the stigma, the taboo that's surrounded this topic for so long? Do you think it's as simple as that they've grown up their whole life thinking UFOs, UAP, oh, that's crazy stuff, there's no point investigating that?
Well, there is some of that, but obviously people change opinions about socially accepted notions of the past, right? So there are lots of heroes from the past that were canceled in recent years, right? And so obviously we should adapt to changing circumstances. And if there is evidence about objects entering the solar system that look weird, we should explore them. I don't see that as as anything related to past reports. And any new object is a new ballgame. And only over the past decade we started detecting interstellar objects. Before that, it was a completely different matter. And I don't, frankly, I don't relate these objects to past reports. Who knows how well the data was documented in the past? I'm just talking about these objects. So it may be an excuse, but it's not a good reason.
No, I agree.
And of course, in a way, by pushing back, you are promoting this ridicule rather than trying to act objectively. So you are actually making it worse because we will never know the answer if we are not investigating it scientifically. So all I'm asking for is to apply the scientific method that we all agree on to peculiar objects that were observed, okay? And just think about it in the mainstream of theoretical particle physics. For 40 years, people advocate notions like the multiverse, extra dimensions. And we have no clue as to whether these notions would ever be tested in our lifetime. Yet they are discussed very extensively as part of the mainstream. And you ask, why is that acceptable? Why don't we hear people saying, oh, these are extraordinary claims, without evidence, we shouldn't discuss them? Why is that not an issue? That violates actually the code of physics, relying on experimental verification, because here we are getting to the point where even in our lifetime, there is no proposed experiment that can be done to test these ideas, and yet they dominate the landscape of discussions. And those practitioners do not even feel the need to justify them working on ideas that will never be tested in their lifetime experimentally, never. Yeah. And so now when there are objects where we have some anomalies and we want to get the evidence, then people have a problem with that. And to me, it basically shows that something is wrong with the social forces within academia, within science, because they do not practice what they preach for. What science preaches for is attending to evidence and collecting evidence actively. That's what we are doing in the context of dark matter searches. We are searching in the dark, and we spend billions of dollars. And if the public really cares more about the question, are we alone? We should spend equal or more money on this question. And now the government, the senators are talking about it seriously. They're talking about it seriously. The Senate majority leader is saying, we want this to be studied. Okay. Yeah. And the public cares a lot. I mean, more than 2/3 of Americans believe in extraterrestrial intelligence. That's bigger than the fraction that believe in God, like less than 50%. So I'm saying, you see, the public cares about it. The politicians in Washington care about it. Scientists like myself care about it. And moreover, artists care about it, because just a few days ago, received an email from a sculptor who is making a 2-meter scale sculpture in my honor. This is a very reputable sculpture.
Wow.
And then a songwriter who won 3 Grammys, 4 Emmys, 2 Oscars, and so forth. He's writing a song about celebrating my research. There is a playwright who wrote a play celebrating this research. And there is a documentary filming crew they were with me on the ship in the Pacific Ocean, and there were 1 out of 50 filmmakers, producers who approached me to do that.
Really?
And I selected them. So it's clear that artists are, yesterday I received an email from an artist who sent me a picture that he made together with AI, inspired by my work. And so if artists are inspired by this, and I know also that the spiritual leaders, like 2 rabbis wrote emails to me saying that they were inspired by my writings to write the sermon for the Jewish high holidays in their synagogues. So you see spiritual leaders, you see artists, you see the general public caring a lot. There were a few million people reading my essays, the diary reports during the expedition around the world, and these were translated to Spanish. And you see the government who cares a lot about it. The only people who are not excited for some reason are in academia. And my guess is that there is a huge majority of people who are silent in academia, and they really follow this with great interest, with great support, but they're afraid of speaking out because there is this group of others who are very vocal and basically cancel the subject and ridicule the discussion and claim that anything in the sky must be rocks. And the latest incarnation of that was on the day that I returned from the expedition. There was a paper published in the Astrophysical Journal saying that the meteor that I went out to explore, actually the data that describes it from the US government was wrong, because their model for stony meteorites cannot fit the data. The object was reported as moving too fast, and they cannot fit it. And therefore, they claim the government data must be wrong. Now, I was brought up with the notion that if your model doesn't fit the data, you revise the model. And that's exactly what I applied to this object. I said, this object must have material strength, tougher than all space rocks we had seen over the past decade in the catalog of NASA. We sort of said that in the paper. However, these people use a model for stony meteorites and say the data must be wrong. The velocity must be a factor of 3 smaller. This is an object not from interstellar space, from the solar system. And moreover, it cannot be made of iron. These are the conclusions of the paper published on the day that I came back from the expedition 2 weeks ago. And I held in my hands the spherules, the molten droplets from the surface of this meteor, because we went to the site. We found the spherules concentrated along the expected meteor path, okay? And we collected more than 50 of them. And I held them in my hand, and preliminary studies on the ship indicated they are made mostly of iron. And these papers say, no, it cannot be made of iron. And the government was wrong. And just a year before that, the US government, the US Space Command under the Department of Defense, issued a formal letter to NASA saying, we looked into the data and we confirm at the 99.999% confidence that this object, this meteor, is of interstellar origin. And this is the same US Space Command responsible for monitoring ballistic missiles headed towards the US, okay? And they have a responsibility, life and death responsibility, for alerting the US government about national security risks. So I ask you, could they make a mistake by a factor of 3, such that a ballistic missile will hit Washington, D.C. when they think it will hit Mexico? I mean, to me, it sounds ridiculous. And moreover, would they write a formal letter to NASA after looking at the data again in great detail and being confident at the 99.999% if there was a good chance that they are wrong? Yet, you have these 2 astronomers 2 weeks ago publishing a paper in the Astrophysical Journal saying that. And that is at the time that I'm bringing back the materials from this meteor. So in a way, blue sky research of the type that I'm conducting makes me sleep better at night because it confirms the location and the inference of the US Space Command about this meteor. I went there, I found it, okay? And I know it's made of iron. So I sleep better at night because if they were wrong by a factor of 3, as this paper claims, then I would be worried that they would never be able to warn us against ballistic missiles. So in a way, basic science makes me sleep better at night.
Yeah, absolutely. Absolutely. Basic exploration and science. I love it. So in terms of the expedition, you got all these spherals, yeah. Spherals. And you found a couple of other little bits and bobs. You've sent this away for analysis now, and right. You're expecting it back when? In any time now, really?
In the coming weeks. So it takes a little more time. I basically shared materials with UC Berkeley, with Harvard University. Most of it is at Harvard University, and also with the Bruker Corporation in Berlin, Germany, because they have a very special instruments that nobody else has. Altogether, I on purpose gave it to experts who will examine it agnostically, professionally, without any bias. They have no skin in the game of interstellar intelligence or anything. And then I get the answers from 3 independent groups. And we will follow rigorous analysis, put the results in a scientific paper and share them with the world. And, that's the way science is done. And surprisingly, there are lots of people who jump to conclusions. They haven't even seen the data. They don't know what we have. And they already raise criticism and skepticism. And I ask, where's that coming from? Why is there so much negativity? Maybe you have a better answer. I don't understand. Why was there negativity before we went? And why is there negativity after we came back? So before we went, people said you will not find anything. After we came back, they tried to say you didn't find anything. And I found that surprising because we actually found something,
Yeah, that is surprising. This is probably too simplistic, to break it down like this. However, there's a part of me that thinks, is that just basic old human jealousy and stubbornness and that kind of thing? Are they jealous? Avi, is getting all this publicity and this funding for this research, and he's doing valuable work, and whereas meanwhile I'm doing this and nobody notices what I'm doing, and
I think you have a point.
It could just be that.
You have a point because one of these critics said explicitly, he said, yes, there is some jealousy in it, but it's about time that science reporters will pay more attention to the boring research that other people are doing. So someone said that, okay?
Yeah.
And I can even send you the link to that. And, I was invited at one point to give a public lecture about this expedition. And just half a day before that, the people who invited me said that the moderator will be one of your fierce critics. And I said, I'm not giving this talk. Why should I suffer? Why do I need to?
Yeah.
And so I said, why don't you ask this person to speak instead of me? And so they did. And this person said, no chance they would find anything. And this was videotaped. It's on record.
Yeah. Brilliant.
And now it's fantastic because I have videotaped record of this person saying what he said.
Yeah.
And put that together with the future scientific paper that we are planning to submit. And that would be the irony of the situation displayed. Because if I were to give the talk, people would say, oh, again, he said these things. Okay, fine. But now I have it on record, what this person said, because he was given the entire amount of time that I was asked to speak for. And anyway, so my point is that I'm trying to be guided by evidence. And indeed, I think there are 2 lessons from this experience. One, that the progress of science should not be diminished by the negative undertones on social media and public statements made by others, or academic jealousy, exactly what you said. But the second most important lesson is that that this science can be exciting. This demonstrates that science, if it resonates with the public's interest and with the government's interest, it can be exciting, and people would love it to see how the scientific process is going, what the evidence shows. And it's like a detective story. It's not a group of scientists lecturing to the public the final findings. It's a question the public wants to be engaged with through the scientific process. So that is a very important point. And, the other thing is that obviously, the best is yet to come. Once we have the results of the analysis, of course, then we can discuss what it means. And experts try to express their opinions without having access to those results. So that again shows that the roots of the negativity are not supported by any substance, because otherwise they would just say, let's wait and see what they find.
Yeah, I mean, I'm excited to see what these results are. I suppose there's no chance they come back before the 26th of July. That would have been something.
It will not happen before that, but hopefully within the coming month, we will be able to share the results, yes.
Yeah, cool. And I know you're not one for speculation, Avi, but I have to ask the question that I'm thinking, that everybody's thinking, is in terms of it being potentially something technological, this object, would you hazard a guess at like a percentage or like a rough, I'd say there's 1 in 10 chance or 3 in 10 or whatever gut feeling you might have. Not your scientific answer, just your personal answer.
Well, so the 2 hints that led me in that path were that the object was moving at 60 kilometers per second outside the solar system relative to the local standard of rest, which is the frame of the Milky Way galaxy. And that is faster than 95% of all the stars in the vicinity of the sun. So perhaps it benefited from propulsion, artificial propulsion. That was the one aspect of it. And the second is that it was tougher than in material strength. It was able to sustain the ram pressure of the surrounding air to a level that is higher than all space rocks in the NASA catalog, 272 of them. So again, that suggested maybe it's made of some artificial alloy. And then, of course, by checking the composition, we could even check the material strength of these spherules, which we are planning to do. We can infer indeed whether it's different from solar system materials, whether it's technological in origin, because if you imagine melting the surface of a technological gadget like Voyager colliding with a planet out there, it would have a different composition than a rock. And especially if you think about semiconductors or computer screens, there would be a much higher abundance of rare elements than you find in nature. So this is to be determined. And one thing to keep in mind is we don't rely just on the surface of the spherules, because that could have been contaminated by the decade that by sediments over the decade that elapsed since those spherules sank on the ocean floor. I mean, basically they are just molten droplets from the surface of the object when it was exposed to the immense heat associated with the fireball that released a few percent of the Hiroshima atomic bomb energy into 500 kilograms of matter. And so these droplets rained down and fell on the ocean floor almost a decade ago. And we are trying, to study them now after we retrieved them with a magnetic sled, a sled covered with magnets on both sides that was connected to the ship by a cable. And let's see what we find. I mean, I received the materials just a week ago by FedEx. Here is an example for how a vial looks like from the last run that we didn't have time to analyze. So most of the material we found was volcanic ash, black powder from volcanic activity. That's the most abundant constituent. But among those tiny particles that make the volcanic ash, there are bigger particles that are the molten droplets. And these are the spherules that look like spheres. Metallic marbles, beautiful. I mean, they have gold, brown, green colors. And so we are planning to study those. And let's see what we find. And so when you ask me what is the likelihood, I hate to guess, because it really, it's a straightforward experimental procedure where we just measure it, and then based on what we see, we will try to figure out what it means. And I will be glad to answer your question in a few weeks. We just need patience. I would say, given the circumstances that the material strength was high, even if it's natural, it would tell us something new, because presumably it didn't come from an environment like the solar system, and that would be amazing. The other thing I should say, the collisions, based on the statistics of this catalog, collisions of meter-sized objects from interstellar space occur once per decade with Earth. But Earth has a small cross-sectional area relative to the area associated with the orbit of the Earth around the Sun. So it turns out that within that volume that is bounded by the orbit of the Earth around the Sun, there are about 1 million such objects, meter-scale objects from interstellar space, at any given time. And we happen to collide with one of them every decade, every 10 circles around the Sun. So one can think of a better way of finding them. We can't see them with telescopes because they're only 1 meter in size, so they reflect very little sunlight. They're too faint to be visible to us. We can see only objects that are bigger by a factor of 100 or 200, like oumuamua was. But we can't see these tiny ones that are 1 meter in scale, and they are 1 million times more abundant than oumuamua. And there might be ways of finding them without them hitting the Earth. But as of now, going after them in space would cost billions of dollars, and doing the expedition was just $1.5 million. So it's a more practical approach. And there is a second interstellar meteor that we are also thinking about exploring in the future.
Yeah, absolutely. Maybe to fund that one, you could sell one of these spherules on a necklace. I think your daughter said that to you. You wrote it in your Medium blog.
Right. We are not making any commercial profit out of it. That's because it's a scientific project. And when I was asked by FedEx to declare, when I sent materials to Germany, they asked me to declare the content, and I said sand. And when they asked me to express or write down the commercial value, I said no commercial value, because it has only intellectual value. It's a very little amount of materials, after all. It's sort of like a teaspoon of about 50 milligrams in total.
It's like if you emptied your pockets after a day at the beach. It's just the stuff that falls out.
Yes, except the grains are very special, and they were 2 kilometers deep. So that was the challenge. And I'm still struck by this miracle that we found them. I was very worried that we won't find anything. And after we found it and we celebrated with champagne on the ship, I asked the coordinator of the expedition, Rob McCallum, why did he bring champagne? Because I wasn't at all clear that we would find anything. And he said that he's an optimist. And my lesson is that life is a self-fulfilling prophecy. So it's worth being an optimist.
Yeah, absolutely. Maybe it was his preparation that helped you find them. Maybe the bringing of the champagne.
Actually, that morning before the champagne, the filming crew on the ship decided to film me in my morning jog, which I do every morning at sunrise, also on the ship. And they asked me, are you running away from something or running towards something? And I said, I'm running away from some of my colleagues who have strong opinions without seeking evidence. And I'm running towards a higher intelligence in interstellar space.
Yeah, and towards the evidence. Nice.
And towards the evidence, exactly.
Another thing that you said when we spoke last time, a year ago, you said about the expedition that you get seasick and that you were going to, you're willing to put your body through it in the name of science. So how did you hold up? How was the seasickness? Was it rough?
I took pills of bonin, which apparently resolved this matter. And I think I was so excited about the science. When we found the first spherule, saw it on a microscope image, I simply hugged the person next to me that saw it first, Ryan Weed, because, to me, it was the success of the mission. We were there to find something from that meteor, and here we found those droplets. And So I think that overwhelmed any health-related issues like seasickness. And I actually didn't sleep regularly. I would sleep for a few hours at a time in the conference room on the sofa. I didn't go to the cabin. And I had to write all these diary reports, which took a lot of time, but apparently millions of people read them. So you might say I was on a high, even though there was no alcohol throughout this, on a high as a result of the scientific mission. And the physical conditions did not bother me at all. They were completely secondary. We had a fantastic chef that made excellent food. And I should say the team that was on the ship, each person contributed professionally, selflessly, and if I were to take out any individual on the ship, we wouldn't make it. So it was a team effort. And that, led me to write an essay just a couple of days ago titled, "We Are All in the Same Boat." So on the ship, I realized that being in the same boat, is allowing or at least encouraging people to collaborate. Because we all share the same fate. And we should all recognize that this is a metaphor to our situation on Earth. You can think of Earth as a boat traveling through space, and we are all in the same boat. And instead of focusing on the mission that we have, prosperity and curiosity-driven knowledge about the universe and so forth. Instead of that, we focus on the boat itself and on fighting each other about territories within the boat, and which is really tragic if you think about it from a distant perspective. Someone looks at Earth and says, "What are they doing? They focus on irrelevant things. They're wasting their time and energy instead of doing the real thing." And so, to me, it's a metaphor to how we can behave, because the crew on the boat, on the ship, was amazing. I mean, we worked together, and every person contributed without expecting any personal benefit, and that's the key for the success of the mission. And hopefully, humanity can learn a lesson. That's partly what I say in my book, Interstellar, which basically sends the same message to humanity. And if you want to read more, of course, you can find it next month, and you can pre-order already.
Yeah, but you're so right about planet Earth and how messed up the way we're running it is. You think about it, okay, imagine in 50 years we have a telescope and forget the UFO stuff and your search for stuff in the oceans, but just say in this hypothetical situation, we make a massive telescope, James Webb times 10, and we manage to see, we see a planet, whatever, we see a civilization, and we say, wow, we found a planet with alien life on it, and there's one dominant species. And they've split into more than 200 different groups, and they all talk different languages. They fight each other, they kill each other, they don't share resources. In fact, they kill each other for the resources. Like, it's insane.
It's insane.
What are we doing?
It's insane. It's
madness.
I did a simple calculation that we spend $2 trillion a year on military budgets and worldwide. And if we were to listen to the words of the song of John Lennon, imagine all the people living in peace, and just stop fighting, we would have a surplus of $2 trillion a year, and that we can invest in space exploration. So I calculated that within this century, we will be able to send a probe to every star in the Milky Way galaxy, tens of billions of them, if we were just to do that. If it takes less than a century to do that, then another civilization, which is intelligently led, could have done that. And therefore, we should be able to find any relics around us. So in a way, there is a selection effect where the most visible technological civilizations across interstellar space would be the most successful ones. And we can learn from them.
Yeah, we have a lot of learning.
I mean, they would arrive to our doorstep before we arrive to theirs, because our interstellar probes will exit the solar system only in 10,000 years. So if we see anything from others that preceded us, they are likely to be much more advanced than we are.
Yeah. And we're not going to go down this road now, but it's just making me think of a question, is like, again, a hypothetical. How would we approach a civilization that had split themselves into over 200 groups? Like, that's a logistical nightmare, really, isn't it? It's like you talk about take me to your leader, but
no. So the point is that I don't think biological creatures are suited for interstellar travel because it takes a very long time. Much more than a generation. It takes 50,000 years to reach the nearest star, and it will take 500 million years to traverse the Milky Way galaxy with chemical rockets. So it's really a huge amount of time, but biology was not designed for that purpose. It's designed to survive on the surface of a habitable planet, but going into space brings a lot of hazards, like high energy cosmic rays that could damage cells in our body, the lack of nutrients over such a long period of time, the lack of energy, and so forth. There are lots of issues and the possible risks from damage to the spacecraft along the path. And so it makes much more sense to build a technological device that would be hardened and could be dormant until it reaches the destination and then wake up. And it can be designed for the task. Okay, so we can serve as the designers of such a technological probe, and the same should hold for another civilization. I think it's most likely that we will encounter some device that was designed for very long journeys, and it's equipped with artificial intelligence if it is functional, because it cannot wait for guidance. Even light takes tens of thousands of years to cross the Milky Way galaxy. So we cannot rely on the sender to tell the gadget what to do. We need to have the gadget decide for itself on a short time scale how to respond to changing circumstances. And that implies artificial intelligence. So that's what I imagine for a functional device. And then it could be that the vast majority of items would be trash, space trash, just like plastics in the ocean, and keeps accumulating over time, and maybe made of lightweight materials that float under the influence of radiation pressure. So, for example, oumuamua showed the push away from the sun that I interpreted as being as a result of the reflection of sunlight. And recently I wrote a paper explaining that it could be, for example, a piece of a broken Dyson sphere. So a Dyson sphere was a concept that Freeman Dyson came up with about 60 years ago. And he basically argued that an advanced civilization would try to harvest most of the energy of the host star by building a megastructure around it, like a sphere. And of course, it's very difficult to make the sphere rigid because there are huge stresses by gravity on such a structure. So it makes much more sense to have tiles that overlap, and they can hover above the star by balancing that gravitational attraction to the star with the radiation force pushing them out. So sort of like kites that hover above the stars and overlap. So these tiles overlap. But the idea is that when the star gets hotter and more luminous, it will blow up this structure, and then you will end up with those pieces floating in interstellar space. To start with, they're already balancing gravity by radiation pressure. So eventually it would be very easy for the star to basically kick them out of the planetary system because they're not bound to it by gravity. And so that would be a source of lots of thin filaments or films or membranes in interstellar space. And perhaps Oumuamua was one of them. And another possibility is that it was the surface layer of some device that was sent to space. And we just don't know. But at any event, space trash may be the most abundant source of objects in interstellar space, but there could also be functional devices like the US government is talking about UAP, which are not understood and could be from outside of this Earth. At any event, we need to figure out their origin based on data, based on evidence, and we need to collect that evidence. It's our responsibility. Nobody would do it for us.
No, absolutely. And on the subject of that evidence, okay, so you mentioned that some people in the Pentagon or the US government reached out while you were on the expedition to say like good job or whatever, or keep it up. I don't know exactly what the communications were, but it seems like kind of words of encouragement. And I wanted to ask, in terms of if the analysis comes back and you're confident that shows you that this is technological and interstellar, which would obviously be an enormous, a monumental moment. But if that comes back and that's what you find out, okay, it's technological and it's interstellar, do you feel any sense of duty to go to the government or the Pentagon and inform them before informing the people, or do you think you just go straight out with it, publish it, get it out there?
Yeah, I will go out to the public.
No
this, as I said, the oceans or the sky are not classified, and there is no special status that the government gets in the context of scientific deliberations. It's knowledge that should be shared by all humans. And I don't think the government wants anything to be censored that is purely scientific. They worry. I mean, they are not releasing data just because it was collected by sensors that are classified. So it's not so much about the data; it's more about the sensors being used. They don't want adversaries to be aware of the type of sensors, the quality of sensors being used by the U.S. government. That's their concern. And in that context, if we find some truth about an interstellar meteor, it's just like finding something about the Big Bang or the composition of the universe or the nature of the cosmic expansion. These are items that have nothing to do with national security, and they should not be privileged to know about them first. The government has no privilege in that context. I don't see any. They didn't ask for any. I think they are really puzzled by some objects that they're seeing. That's fundamentally what's going on. And I don't believe in conspiracies. I think they're puzzled, but they don't have the ability to revisit those anecdotal reports. These are reports that were a one-time event, and they can't go back and get better data. So the better approach is actually to do a systematic search for such unidentified anomalous phenomena. And then that's what the Galileo Project is doing, that I'm leading. And we have an observatory that is already functioning at Harvard University. We're planning to make 5 copies of it already funded, committed to. And the idea is to monitor the sky 24/7 and analyze the data with machine learning algorithms. And when you do a systematic study of this type, it's not only that you may find more events because you are not relying on pure chance of someone being at the right place at the right time, but more that it's that the background, how frequently these things are. It's not it's not circumstances that allow you to figure it out, but you monitor the sky for a certain period of time and you see these objects, so you can calibrate their statistics. You can expect to see them again after a similar amount of survey time and area. So, and you also are in full control over your instruments. They are well calibrated. You know exactly what the instruments were doing at the time the data was taken. And it's not relying on the human experience. It's instruments doing it, cameras.
Yeah.
So all of that is in the spirit of how science is done. And that's the way we pursue it with the Galileo Project. And it's currently the only group scientific research program that is aiming to do that. I mean, there are lots of other groups that are either discussing past events, past reports, where, again, the unfortunate fact is that the data was anecdotal, sometimes based on eyewitness testimonies, not even instruments data. So we can't really improve it. If it's unclear, then we can't tell what it is. And so we are the only group that is doing new research into this as of now.
And what valuable research it is. You've submitted, I think, 7 papers with the Galileo Project.
Yes. They are published in the Journal of Astronomical Instrumentation. And they're online also on the Galileo website. You can see the final versions of them. So they were accepted. These papers detail the design of the instruments, the observatory that we used, and also the other tasks of the Galileo project, like the expedition or trying to search for another oumuamua in outer space. So it's more about the methodology, the approach that the Galileo project is taking to getting more evidence, more data. It's not reporting about any new data. So now the next phase is that we're starting to collect new data. We already did that for half a year, and we are now analyzing it. And in the future, we hope in the next year to write another set of papers reporting about their preliminary results. What do they mean? And before that, there would be the expedition paper, of course, because everyone is waiting for that.
Yeah. In terms of the Galileo and the preliminary results that you've had, are you aware of any anomalies so far? Anything that you would qualify as UAP? Have you seen anything yourself directly?
Not that I can speak of publicly at the moment.
Okay. I'll take that. That's interesting. That's definitely not just a no. What are the implications for humanity? You know where I'm going with this. If the results of these expeditions do show that the object was technological and interstellar, what are the implications for humanity?
Well, the implications are huge, and I discuss them in my book. That's the main focus.
I know. That's why I asked you. I got the question from you.
So obviously, it depends on what we find, right? It depends on the details, because if you find space trash, it's very different from finding a functional device. I asked students in my class last semester, what should we do if we find a gadget with buttons on it? Should we press a button? And half of them said, no, we are worried about the consequences. Another half said, yes, we are very curious. And when a student asked me, what would I do? I said I would bring it to a laboratory and study it before engaging with it.
So, I'm not touching that.
So that is, obviously one scenario where we can learn a lot about a new technology that we can import to Earth. And, it's just like, just like Moses finding the 10 Commandments on a tablet and trying to figure out how the tablets get the data and seeing all the advertisements on the internet while checking the 10 Commandments. So trying to figure out what it means, I think 3,500 years ago for Moses would have been a great challenge, actually, looking at the tablet. Although the story is that he looked at a tablet made of stone, not a tablet of the type we are using. But just imagine him going through a real tablet connected to Wi-Fi on Mount Sinai. And seeing the 10 Commandments plus some advertisements. So
and some auto-playing adverts and everything. He's like, what's going on with this thing?
I mean, it would take him a while probably to figure it out, to actually also master the kind of information that he can extract from the internet using that tablet. So I'm not sure, actually, it would have been... he might have been more excited about the technology than about the 10 Commandments at that point. Maybe he
might have even just broken it with a stone. He might have been so scared of it, he just smashed it up.
Actually, he did smash the tablets when he came down the mountain the first time. But the legend is that he did it because he was disappointed by his people that they built the golden statue of that they admired. So, but it's not an easy process to learn about the technology that represents your future, thousands of years into the future. So it will be a challenge for us, but it also is very rewarding because once we figure it out, we can use it. And it may teach us new physics that we are not familiar with, but may also be it may be the case that there is no new physics, that in fact, there is no physics, but it's not really important. Let's put it that way. Like quantum gravity doesn't play an important role in our experiences as of now, and may not play an important role in future technologies. But the quantum mechanics and gravity separately could play a very important role, and we know them. Okay, but the unification of the two may not be relevant for gadgets. And that is possible, that we pretty much know the physics, Nevertheless, the technology that uses that physics could be completely beyond our head. I mean, just like AI nowadays is so much ahead of what we knew decades ago. So you can imagine things like that, and we could import them, and that would be a great benefit. But if we find trash, then it may be more challenging to figure it out and to appreciate what it means. There will not be the same sense of awe that we might have with a functioning device. Aside from the technological benefits, it would change the perspective we have about our life here on Earth, because we would realize there are neighbors out there, and we might want to visit them, and we might want to figure out how many of them are there and what do they do most of the time. And it will change the focus, the priorities that we assign to our life. And perhaps my hope is that it will give us perspective that is grander than we have right now on Earth. And what I mean by that is, instead of being at the throat of each other, we would aspire for something bigger. And just to give you an example, the only bird that is capable of pecking on an eagle is the crow. Okay, so you have these beautiful images of crows sitting on the back of an eagle and pecking on the eagle's neck. And you might say, oh, the eagle should fight with them and kick them out. But no, the eagle ignores them, doesn't waste any time or energy on the crows. The eagle just flies as high as it can, where there is much less oxygen, and the crow just drops off the eagle's back. Yeah. And so that's a metaphor for the way we should behave. And I say that also in the context of social media, because if you mud wrestle with other people, you get dirty. So a much better approach is to fly like an eagle, high up, such that the crows drop off your back. Okay, and just go up to great heights and avoid the crows. And the message to humanity is, let's move away from the crow mentality of pecking on the neck of others, and instead aspire for something grander, greater heights for humanity, which is exploring space, striving to be better, investing our resources for the benefit of technology, science, so that we can extend the longevity of the human species and really prosper technologically, scientifically. I think that is what we should think about. And it's not easy to convince people to do that. And let's start with those people whose day job is to be guided by evidence, the scientific community. Okay, so before we ask our politicians to pay attention to evidence, I would ask our scientists to do the same.
Yeah, that seems fair enough to me. I think from here on out, if it's okay with you, we're going to try and do a bit of quick fire.
Okay.
Just because I have still quite a number of questions, and I want to ask you as many as I can. So we'll just see how many we can get through. I'll do my best, and yeah, we'll do what we can. So, what would it mean for the UFO phenomenon if, again, the same thing I would just asked you, if that you did confirm this was technological and interstellar? Would we need to basically reevaluate everything? Would we need to go in and look at it, see how deep the rabbit hole really goes, see what is connected? Would we need to relook at abductions and things like that, alleged abductions? And would we need to say, is this correlated with the stuff Avi's found?
Well, my advice is to focus on the future, not on the past. So from now on, if we do find it to be real, let's learn as much as possible on it. It's possible that some of the reports from the past are correct. They are intriguing. But if we were to deal with the past, we would never be able to improve the evidence. However, if we try to collect new data, we can always get better and better evidence and eventually figure out all the details of what's going on. So I would say, forget about the past. Let's focus on the future. And it's more exciting. It's like a detective story. You have a role to play. You are collecting that data, and you can shed light on this phenomenon.
Yeah, great. This question, in fact, my next two questions are from one of my patrons. This is Chris Devox. So he says, Dr. Loeb, thank you for your efforts on the UAP topic. One of your ground rules reads, our analysis of the data is based on known physics. how exactly will this be implemented when your data would show objects that maneuver in ways that are unexplainable according to our current understanding of physics?
So my approach is to use known physics as long as it can be it can be used to explain the data. And if you are pushed to a corner where you have exquisite data that doesn't allow conventional explanations, then you contemplate new physics. I'm not excluding new physics. Just like in the context of dark matter,
I was going to say, like you alluded to earlier.
But on the other hand, if Ukrainian astronomers argue for dark objects that move at 15 kilometers per second and have 10 meters size, that violates the idea that such objects should create a fireball around them because they interact with light, they block light, they are dark. Nevertheless, we see them as dark, so they cannot produce a fireball. So something is contradictory here based on known physics. And if your measurement of distance is not very reliable, if you don't do triangulation, I would say you need to do that before you argue for new physics. Okay, so what is the necessary condition for new physics is to have exquisite data that doesn't leave any doubt that the old physics cannot explain what you're seeing. Okay, so that's the way experiments in physics are done. And without the exquisite data, we can't really go that far as to suggest new physics. So I'm not against it. I'm completely open-minded, but I'm just raising the bar to a level where there wouldn't be any doubt that there needs to be new physics. So that's the level of, because we need to convince ourselves that we're missing something really fundamental.
Yeah, you want to be 100% sure that that's what it is before you go off the,
Because I should say the laws of physics apply everywhere. They are not like the legal system in society where some people can violate it, nothing bad happens. The laws of physics are valid everywhere, universally, to all matter in the universe. So if we find new physics, it's extremely powerful because then you can do a lot of other things derived from the same new physics. And so that's why, the bar should be very high, because then we can, if we realize it's real, we can engineer it and make new devices that you didn't even see before.
Yeah. And I suppose in a lot of ways for you, that would be kind of the holy grail, or at least the second best thing after, as you like to say, the part of a spaceship with a label saying made on planet Zorg or whatever. The next best thing would be to have like some evidence that makes you certain that, that doesn't fit.
Well, there is room for a lot of Nobel Prizes. Let's put it that way.
Yeah. This question is from the same guy. So, Dr. Loeb, thank you for your excellent work, this time on the Galileo Project. How did the paper with Dr. Sean Kirkpatrick come to be, and what role did he play in this?
It was very simple. He visited my home. We had a conversation. He suggested that we write a paper together on possible scenarios, how to limit the physical parameters of unidentified aerial phenomena. So he initiated that, and I said, I would be glad to do that. And then we started writing it, and then he was very busy with legislation in Congress for a few months, and eventually we came up with the final version. And at that point, I was not sure whether there is enough new material in this paper, but we spoke, and he said, I think we should try to finish it up. And we did, and then there was a huge amount of attention that I did not expect, frankly, because in my mind, it was just hypothetical, and there wasn't any evidence behind what, the scenarios that we considered. It was just a theoretical paper, but nevertheless, people cared a lot about it, and so be it,
Yeah. I mean, I would say it's easy to see why probably people cared a lot about it. He was the head of the AARO, the government's body, and you're Avi Loeb, Harvard astrophysicist. I think it's kind of a provocative team there that was. Yeah,
but we are both. You can think of a common thread. We are both curious about what UAP mean, and so we were just contemplating possible scenarios. That's all. There was no evidence behind them.
Do you think that, again, you might not want to answer this, but I mean, I'm just trying to kind of like speculate in my mind. Was there a little part in Sean's mind saying, if I can do something with Avi, that's going to help AARO and me look good in the public's eyes, seeing as Yeah,
that's possible.
yeah.
Because I mean, all I know is that he suggested it, and I was happy to work with him.
Yeah,
it was fun,
yeah.
but he came with the initiative. It's not I followed him.
Yeah, yeah. What did you make of him? Again, whatever you're kind of willing
I
to
think
your
he's a
gut feeling. What
very
is him
solid.
as a person?
He has integrity. He's solid. He has good knowledge of physics, and he's just trying to make the best he can out of the limited data on past reports. So he mentioned in a recent testimony that only 4 or 5% of the objects appear to be truly anomalous. That they can figure out what the others are, and I can imagine a lot of balloons in the sky. Obviously the number of UAP correlates with population density. That's one fact that when you look at all the reports, and that means that many of them must be of human origin, because balloons, for example, are everywhere. So you would see many more balloons in populated areas, because more people are looking at the sky and seeing balloons. Okay, so and drones and things like that. So the question is, okay, what are the remaining few percent? And even if it's 1 in 1,000, for me as a scientist, would be of great interest. I think he's coming at it mostly from the national security angle, because he's at the Pentagon, and that's their day job. Okay, and so science, I see, is complementary to the work of government in this context. We are interested in the very small minority of objects that might be from outside of this Earth. He and the government more generally are interested in most of the other objects. They want to know if they have a label made in China on them, for example. And to me, that's a boring label. Anything that says that, I'm happy to give them the data. I don't need it.
Yeah, yeah. I hope the ETs or whoever haven't been putting made in China stickers on their craft just to try and fool us. Let me ask you 2 last questions about Sean before we move on. And I know that you're not, best friends. You're not giving an official character witness or anything like that, but just from your, the time you spent with him. So do you think that he is as interested in open source data as you are? And do you think he has the best interests of the population in mind?
That's my impression.
Yeah. Okay, cool. Well, I'm glad that at least he gave you that impression. We did kind of briefly touch on it earlier, so I guess maybe you already kind of gave your thoughts on that, I guess, on David Grusch. You already shared your thoughts.
David Grusch is sincere. I mean, I believe him, he's sincere, but the question is whether other people tricked him. Okay, so he heard from other people and from written reports some things, and the question is whether these are real. Okay, because you can imagine other people playing games with him. And so if more people come forward, there is a hearing in Congress on the 26th of July, and we shall see. I mean, if it's real, then eventually it will come out, and I'm very curious to know what's behind it. I'm a scientist, and I basically respond to evidence, real evidence, not to what people say.
Yeah, I know, but I appreciate that you're not, like some scientists would do and would say, "Oh, I'm just totally not interested at all." Like, it's still a very credible person making very intriguing claims.
I mean, definitely, and because of the gravity of the implications, I think a lot of mainstream newspapers avoided reporting about it. It's not so much that the story by itself was not credible; it's more if it's true, the implications are huge, and therefore they wanted to be careful and not spread too much interest ahead of time. I think that was a very delicate balance that people had to dance to, because the worry is that, okay, if they were to talk about it seriously, then it would be a huge item, okay? And then if they are not sure, because he didn't really see anything, and so then they would keep the lid on it. That was the calculation, I think, that some mainstream media played. But the more evidence we have, I mean, the more people talk about it from different angles, the discussion in Congress, the Schumer rounds legislation, the amendment that they proposed. If all of these move forward, we are likely to eventually get to the bottom of it. And if in retrospect, it doesn't really matter what the media did. It doesn't really matter what the media said. It doesn't really matter what the media did. It doesn't really matter what the media said. 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 It do if there is something real out there, it's just like it doesn't really matter what is said on social media. If there is something real, eventually it will show up. Like, just imagine social media during the days of Galileo Galilei. They would have canceled him for sure. It wouldn't change the orbit of the Earth around the sun. And moreover, if we were to be trapped in this social media narrative that Galileo must be wrong and it's completely stupid to even think about the possibility that the Earth is moving around the sun, and we would launch a spacecraft towards Mars, trying to get to Mars in the space age, we would never get there because we had the wrong model. And then guess what all these social media outlets would say? Oh, maybe it's something, maybe the data is wrong about this spacecraft. But the point is, reality is whatever it is. Humans can refuse to admit it. But at the end of the day, if you want to adapt to reality, you have to know what it is. And if you refuse to accept it, you will just be fooled over and over again. Eventually, you realize you're going on the wrong path. And putting makeup on your face just to look better, it does not change your appearance at the end of the day. It may change it in the eyes of some people, just like social media works. It's the psychology, but it's the physical reality that we all share is something. Okay, and if we have neighbors, we have neighbors. You can't change the fact that you have neighbors on the street just by closing your door and the shades on your windows and saying, I don't see anything. I mean, you will not see anything, but your neighbors would still be there.
Yeah, absolutely. And they'll still be watching you. Either before or after Grusch, has anyone ever told you, either probably in a non-official capacity, but in any, in any capacity at all, have they ever mentioned to you anything about crash retrieval programs or crash retrieval?
To me, that was a surprise. And the other surprise was they came just a week before we went on the expedition to retrieve materials from the crash site of the first interstellar meteor. So the coincidence may be just a coincidence, but it was interesting. I
feel like the universe is planning it.
Well, or some people that have some knowledge said, okay, now is the right time. I don't know.
Yeah.
But the point is that to me, it was a surprise. I used to ask this question, do they have any physical materials? But I didn't know about it.
Yeah. I used to, it's one of those questions that 6 weeks ago, I think everybody felt a lot more, awkward to talk about. And now it's like, okay, we're allowed to actually talk about that and discuss that, even if we're not discussing it in the sense of like, how many have they got? Well, I mean, maybe some people are now, but it's now the stigma, you can actively feel the stigma waning day by day as we go. So this is going to be fascinating to see.
That's the only way we can get to the bottom of the truth, and especially allowing the government to come forward if it's not a matter of national security, so they don't feel that they would be ridiculed. Because one of the things is maybe within government that people worried about their reputation, the response to government if it were to come out with the evidence. And in that sense, me going to this expedition also serves as an encouragement to people who know about something to come out.
Definitely, absolutely. What evidence would you need to see to have confidence in what Grusch has said?
Very simple.
Would it be photo, video? Yeah, go
on. Well, the best would be if we had access to the materials, then we can examine them. And I don't know if any scientists did that already. It's possible that they shared it with some small group of scientists. But, having it in the open allows you to critically examine it. Okay, so I have access to exceptional instruments right now that we are using in the context of the materials from the expedition. And we can apply the same instruments within a matter of days to whatever materials the US government has, and infer, first of all, that it's interstellar, that it's not solar system material. So that rules out anything manufactured by humans within the solar system, because that you can date the age of materials by some isotope ratios, and we can tell whether materials came from interstellar space, because in other locations the relative abundance of isotopes is different. Of elements could be different. So there is a way of telling, and it's objective and it's fairly quick, in a matter of days. So that would be my hope that if there is something, they would share it with scientists who can examine it, or maybe they did it already and we can just see the results. I mean, these need to be reputable scientists that stand behind the analysis. If they don't have such, then I'm happy to do it for them. Okay, just apply the same tools that we use in the context of the expedition materials to their materials. Okay, and figure out the same things. Is it solar system material? Second question, is it technologically manufactured? And it's also possible. I mean, it's also possible that aside from just materials, they have some large pieces that indicates technological origin, and then we can obviously do much better in terms of seeing what it is and gauging whether it's human-made or not. Okay, and I would love to have access to it if it's possible, but if not, to see what other scientists concluded by looking at it. So that would be amazing, because it would change the paradigm in the way that people think about it. If the government has access, and as I said, it's very natural that the US government would be the first, because that's their day job. They have to monitor the sky for ballistic missiles, for dangers, for spying balloons, the Chinese one most recently. So they can see unusual things out there, and they might even fire those things if they feel that they pose a risk to military personnel or to some facilities. So you can imagine scenarios by which the US government engages with objects because they think it's from adversaries, they don't know what they are, and they shoot them down. And so then they check them and they see, oh no, it's actually not human-made. What is this thing? I mean, it's possible. I want to know if that was the case.
And of course, they did that earlier this year. They wildly shot down some things. They didn't know what they were, and then they're like, "Well, we can't find it. We still don't know what it is."
Okay, but these were probably balloons. I bet you.
Probably. Yeah. But of course, we don't know.
They didn't release the data to the public, to news agencies. But I bet you that they have good. I mean, these were balloons. Yeah.
Yeah, I mean, I've said all along, if they truly couldn't find that debris, then there's something really wrong. That they're shooting something down and not watching, to where it lands. And I mean, anyway, that's an old story now compared to everything else that we're dealing with.
Well,
let me.
Go ahead.
Is there anything else you want to say on that quickly before we move on?
No, we can move on. Go ahead.
Yeah, let's move on. I asked you a minute ago if anybody has, mentioned to you about crash retrievals. Maybe a better question would be that since David Grusch has come forward, has anybody spoken to you and said, Avi, he's for real, by the way, or Avi, I'm not sure about this guy?
No.
Or, has anybody come to you and no?
No, but
would you tell me if they had?
Oh, I would, because I'm not signed to any non-disclosure agreement. I have no access.
And I know you don't want to be.
And I don't want to be, so that I'm free to pursue scientific work. Yeah. Nobody reached out to me and nobody told me anything.
Yeah. Okay. How many scientists and academics have, because again, earlier you mentioned that you've had obviously your fair share of skeptics saying to you, why are you doing this? How many, if any, I'm hoping there have been some scientists and academics have approached you and said, Avi, thanks for doing what you're doing. Like, you've actually opened my mind to this, or you've made me look twice at this phenomenon or reconsider. Have you had anybody approach you like that?
I had a lot of young people and also some more senior people, but they remain personal rather than public, okay, on this subject. They approach me and tell me about it. Just like a lot of fans in the general public, among artists, among, even in government, people that admire the work being done and say, keep doing it, we really need you, and, please stay in good health. And so there are lots of those people, and those, some of them were in leadership positions, very important leadership positions within society. So, and including very wealthy people as well. So I would say there is a lot of support, but there is this fear, at least within academia, of speaking out about it this way, because then the wild guy, those that are attacking on social media, that are extremely negative, that they immediately jump like attack dogs, like they go straight to the throat. And those, are vicious. They just make unsubstantiated claims. Like one of them would say, oh, Avi should have hired some postdocs that know anything about meteors, and as if he's just a cosmologist, he doesn't know anything. And this guy doesn't even know that I send materials to 3 independent laboratories with the best experts, the best instruments in the world to analyze it. We are doing rigorous scientific work. He didn't check who I am using to analyze them, and yet he makes these statements. And I ask, why would people invent lies that have no foundation? And there are many such examples. I will not go into all of them because it's a waste of our time, and also they are lies. And so people would just invent a story in their head and say, oh, why wouldn't he do that? And why does he do that? And oh, this must be ordinary materials. But you don't know what I have. So how can you say what I have, what the nature of what I have is? It shows you a lack of professional practice amongst scientists. These are scientists, some of them. And also a willingness to believe anything that would dismiss or ridicule the scientific work that is being done. And it's just inappropriate and unfortunate because it discourages young scientists from innovating. They see all of this behavior. And unfortunately, there is no police, intellectual police, that basically says, look, this is, you're basically doing a crime by using force in ways that are uncivilized, and some people are doing that. I don't respond to those. I take that now after experiencing this for a while. I take the high road of the eagle. I just go to great heights where these people have no oxygen. So, for example, if I were to publish the paper and it will be based on exquisite data, that what can they say?
Yeah. Just keep soaring, Avi. Just keep soaring higher and higher. But yeah, nothing is more frustrating, or not many things are more frustrating than people who say, yeah, that can't be real, or that's wrong, but I'm not going to look at the data. I don't need to look at the data to tell you that that's wrong, or that, that
there was another, I can give you another example. There was a paper in Nature just a couple of months ago arguing that oumuamua was a water iceberg. And within a day after the appearance of this paper, we found a mistake by several orders of magnitude in the energy equation. So I wrote a paper with my colleague Thim Huang saying there was a mistake in the energy equation. It changes everything. The model is not viable. And the science reporters who just mentioned it the previous day in all major newspapers, I approached them and said, look, there was a mistake in the paper. You don't need to say anything. Just say Avi Loeb found claims that there is a mistake. No, they went back to the authors of that paper, and the authors said, oh, their paper was not refereed yet. And so they came back to me, these science reporters, and said, we don't want to confuse our readers, therefore we will not report about the mistake. So I said, okay. I waited 3 months. My paper was now accepted for publication after being peer-reviewed, and with not much change. So now the paper still says there was a mistake in the energy equation. The other paper is wrong. I went back to those science reporters. I didn't hear back from them. So the point is, if they say they don't want to confuse the readership, they should have immediately corrected the previous story. Shouldn't they?
No, because they don't want to confuse the readership, but they don't mind misinforming the readership. That's fine. Yeah. They just don't want anybody to be confused.
But also the authors of the paper saying, oh, this is just not peer-reviewed yet, instead of saying, no, our explanation is, given what they say, actually, it doesn't make a difference because of this and that. That's a valid argument. Intellectually, you can just respond to them, whatever. No, but instead they said, oh, this paper was not referred, as if, that's a very nice political way of avoiding the question. But science is not, science is better than politics. And these people, the authors, were much younger than I am. So I'm just asking, let's practice science the way it's supposed to be. And even young people are not following that. And, so I'm really disappointed that we are not following logic, following the evidence, following the scientific practice in dealing with scientific matters.
Yeah, keep politics out of science. So what do you think the next 12 months are going to hold, for you personally, for the Galileo Project, and for the UAP kind of topic phenomenon in general?
Well, first, on the artistic front, there will be a new play shown about the experiences I have as a scientist. That should be fun.
That's cool.
There would be a new documentary produced That should be fun.
Do you know when that's coming out?
Which one?
The documentary.
Oh, it probably take another year.
Yeah. Okay.
Or maybe a year and a half. And then, so on the scientific front, we'll continue to collect the data through the Galileo Project. It depends what we find in the analysis of the expedition materials as to what the future might hold, because we will likely go to another expedition if it looks intriguing. And beyond that, there is this game changer, depending on what the government does, with respect to the additional witnesses that will come forward and say the government has possession of some materials and so forth. So there are many uncertainties about what will happen in the coming year, but the trend is that we are getting to an important milestone in human history, I think. Let's just wait and see how it unfolds. And it should be very exciting. And let's speak again in a year and talk about it.
Yeah, absolutely. Yeah, I can't wait. Yeah, it does feel like we're very close we're on the precipice of like a monumental shift in our understanding, which is super exciting. And obviously it's great to have you kind of close to the front lines of that. That's awesome. Let me just ask you just one or two more questions, if that's all right. We'll just keep it, under 5 minutes or so. They're going to be quick ones, probably. So I think I asked you earlier if you saw any UAP while you've been, researching with the Galileo Project. But in general, have you seen any UAP, since we last spoke, or have you any lights in the sky, anything unusual?
Not personally, no.
No. Okay. And I won't push you on the data anymore. We'll wait for that to come out hopefully soon. When will we be able to find, when will that all come out, the preliminary data?
For
the
we
Galileo?
Just decided we need a few more months to analyze the existing data. So it will not happen in the immediate future. Maybe within a year, we will have them out.
Okay, cool. So apart from UAP and UFO, have you ever had any other extraordinary experiences? I'm thinking things like a near-death experience or potentially a dream that that ended up mirroring something that happened in the future. Nothing like that? No. Okay, fair enough. And are you comfortable sharing this? And if so, what are your thoughts? I'll kind of, just to give a little bit of background to this. One half of my podcast covers UFOs and are we alone in the universe, on Earth, what have you, and there's the other elements that's kind of what's the nature of reality, what happens after we die. So I wonder, in terms of that last question, have you got any thoughts on that, any personal beliefs? What do you think happens after?
I think it's just like taking a computer electric connection out. Basically, you turn the off switch, and that's what happens when you die. I mean, so your body stops functioning, it deteriorates, turns back to Earth, and there is nothing more to it. And I'm quite convinced that there is nothing spectacular about humans, or about consciousness, or about what we tend to think about our intelligence that cannot be mimicked by a technological gadget. So I think AI would get to the level of any feature of our human experience. Okay, I think obviously when people talk about consciousness, the only place where you can actually testify that you know it exists is yourself. I mean, you can't really tell and claiming that consciousness is unique to humans and cannot be part of the AI experience, I think is false, because obviously AI is not myself, just like any other human is not myself, but it would look as if the AI has consciousness just like any other human has, to me. So I do think that it gives us a good model for how our physical bodies can generate emergent phenomena that we attribute to the soul, to the human spirit, to free will. That's another illusion that we have. Well, basically, free will is the fact that we are influenced by a huge number of factors in anything we do, and there are lots of uncertainties, because some of them are driven by environment, some of them are completely chaotic, probabilistic, and when you bring together, and if you try to forecast a very complex machine, the way it would operate, if it's sensitive to a huge number of parameters, you won't be able to. But whether the machine has free will or not, I mean, it's pretty obvious. You built it out of ingredients, and it's just a very complex machine. That's all. So it's hard to forecast its decisions just because it's complex and it's influenced by a lot of factors, but that doesn't give it freedom of will. And the same is true about humans. So I think we're just, equivalent to a machine in a way. We have a human body, we have the human brain. They are very complex, but already GPT, Chat GPT, it gets to the same number of connections as the number of synapses in the human brain, and we start to notice some similar complexity in the way that it operates. So I do think that in the distant future, we'll realize that there is nothing really unique about humans. It's just they are very complex. As to the origins of how we came to exist, you may argue whether it's just natural evolution. We were chimpanzees and somehow circumstances changed us to humans. Or you can argue that there was some intervention by some interstellar gardener that came over and changed things. I'm agnostic about that, but it's clear to me that we are physical objects that are just complex. That's all.
Interesting, and thank you for sharing your thoughts. I wish we had another 2 hours because I'd love to talk to you a little bit about the evidence for survival of consciousness and the evidence for consciousness being more than just a product of the brain. But obviously we don't have time for that now, and I respect your thoughts on it. I'm sure you haven't been able to go into it in much detail anyway in terms of the research because there's only so many hours in the day, and you're obviously a very busy man. But I will just say that there is quite a lot of very, very interesting research in these areas. So maybe another day we
I
can
agree, and I
it.
think the AI offers us a good laboratory for testing many of these ideas in the coming years.
Yeah, and AI is another crazy road. Like, where's that going to go? That's wild stuff. The advancements that have been made, even in the last 2 months, are just blowing my mind.
Right. So let's talk again in a year, and then we'll have more about AI as well.
Yeah, definitely. And all I'll say in terms of the survival of consciousness and consciousness, as you say to your colleagues, just keep your mind open. That's all I'll say. Don't completely close it off. Just keep it that little ajar.
Yeah,
I appreciate that and I respect that. Any last words for people that have watched or listened?
The fundamental principle that I try to convey is that of modesty, that we are not special, not unique, we are not privileged in the universe, and we can learn from it. So that is my message. Stay modest.
Brilliant. Thank you so much, Avi. I really appreciate your time. You've been really generous with that, and I've enjoyed this as I knew I would. Yeah, you're a lot of fun to talk to. Looking forward to the next one.
Thank you.
Who knows what the world will be like then?
Yeah, I look forward to that.
Thank you to Avi Loeb for talking with me. Thank you for listening, and thank you to our patrons for helping us to do what we do. If you enjoyed the interview and want to continue unraveling the universe with us, please subscribe. And if you want to help us keep making content, please consider a small monthly contribution via Patreon. Thank you.